Congratulations! You have been hand-selected to be part of a skilled team of time-traveling paleontologists. The year is 3118, and humans have figured out the technology necessary for time travel. Our team of paleontologists have discovered fossil remains of the now extinct giant panda. As such, we are sending you back to the year 2000 to observe this creature while it was alive and bring back as much information as possible. You will need to understand the following material in order to complete your upcoming mission. Be ready to teleport immediately upon entering your classroom tomorrow. Best of luck! Let's begin with rock types. There are three main rock types: metamorphic, created by applying heat and/or pressure to igneous and sedimentary rocks; igneous, created by the cooling of magmas and lavas; and sedimentary, created by the redeposition of sediments of eroded igneous, metamorphic, and sedimentary rocks. Because igneous and metamorphic rocks are subject to immense amount of heat and/or pressure, fossils are rarely ever preserved in them and almost exclusively within sedimentary rocks. Speaking of fossils, let's discuss how fossils are formed. Once an animal dies, its remains decay quickly and are scavenged and trampled by other animals. If an animal has any hope of becoming fossilized, it must be buried rapidly upon death. Sadly, most animal remains won't make it into the fossil record, either due to a lack of hard parts or bones, think things like jellyfish or insects, or because the remains are not preserved quickly enough. After hundreds of thousands to millions of years, the sediments and bones become hardened through a process called lithification, which is just a fancy way to say become a rock. At this time, a fossil is formed. After many more thousands to millions of years, those sediments become eroded and the fossils become exposed for paleontologists to find. Once the remains of an animal are buried, water begins to seep into the hollow spaces of the bone or shell, much like water soaks into the pores of a sponge. The water reacts with the bone or shell material and causes it to recrystallize and become hardened, much like the physical change that occurs when water freezes from liquid to ice. This process is called permineralization. Another process that occurs during fossilization is replacement. Replacement occurs when new minerals replace the original bone or shell material. This would be like replacing the water that seeps into a sponge, or in this case the bones and shells, with Kool-Aid. Most fossils will undergo a mixture of both permineralization and replacement. Now let's discuss how we can use rocks and the fossils they contain to tell time. Well, geologic time, that is. The principle of original horizontality states that all sediments are deposited horizontally on top of one another, much like layers in a multi-layer cake. The Grand Canyon is a great example. Notice how rock layers are stacked horizontally on top of one another. The principle of lateral continuity states that layers of sediment initially extend laterally in all directions. In other words, they are laterally continuous. As a result, rocks that are otherwise similar, but are now separated by something like a valley or another erosional feature, can be assumed to have been originally continuous. Notice how the same sequence of rocks appears in each section of the Grand Canyon, even though they are separated by canyons and valleys. The principle of superposition states that for rocks deposited in layers, the youngest layer is on top and the oldest on bottom, each layer being younger than the one beneath it and older than the one above it. This means that the gray rock layers near the bottom of the Grand Canyon are older than the red rock layers near the top of the Grand Canyon. The principle of faunal succession states that there are certain organisms that lived only during specific time intervals during Earth's history, such as T. rex living only during the Mesozoic period. So we can use the fossils of those organisms to figure out where we are at in geologic time. Even in the Grand Canyon, each rock layer has its own unique and reliable set of fossil animals and plants. By using relative dating principles, geologists were able to construct accurate geologic timescales of Earth's history long before technological inventions allowed us to determine numerical, or absolute, ages, as indicated on the far right of the timescale. Much like your own life is affected by ups and downs, take for instance times when you're really happy and times when you're really upset. The history of life on Earth has also experienced major ups and downs. Major ups in Earth's history include times of origination. This is when many different types of organisms appear in a seemingly rapid span of geologic time. One example of a major origination event in Earth's history occurred 540 million years ago and is called the Cambrian radiation or Cambrian explosion because an amazing variety and abundance of ocean animals showed up almost all at once, like a sudden explosion of sea life in the oceans. However, in life, every high has its complement of lows. As such, Earth's history also includes some major downs. At least 5 mass extinctions have occurred throughout Earth's history, and each has had profound effects on the animals and plants that were present during that time, as well as the trajectory of life going forward. Major events in Earth's history, which also include things like volcanism and plate tectonics, have created and shaped the world we know around us today. We look forward to having your expertise and assistance on our upcoming mission. See you soon!